I'd like to introduce the person that runs this district, one of the best bosses I've ever worked for, somebody with great vision for you and for future generations of Oxnard Oxnard Union High School students, Dr. Gabe Samakian.
Thank you, Dr. Weaver. I'll keep this short. I think it's really exciting, and for a lot of us, once in a lifetime opportunity to have astronaut James Kelly here, and I will not officially introduce him, but it's a just wonderful experience. Again, what we're trying to do is not just have you come to school and look at textbooks, but experience the content, knowledge, and apply it to real world settings. I don't think there's anything more fitting than you being here, so thank you very much. I'd like to introduce Kelly Churchman, teacher at Oxnard High School. And it's by no accident that today is happening, and so we thank you for all the connections that you've been able to make, and we appreciate everything that you're doing for our students. Thank you very much.
Hi, you guys. Most of you know me as a science teacher here at Oxnard, and I was lucky enough to bring in a friend of mine, and I wanted to tell you a little bit about how this all came about. I teach for science, and I wanted to bring in a guest speaker, and I thought about who I could invite, and I thought back to a person I knew when I was growing up. So an interesting part of this is that you never know who you know at this point in your life who's going to turn into somebody who might have a really interesting career and who can share that with you and show what hard work and education can do for their lives. So today, you're going to have astronaut Jim Kelly here because I know a person named Julie Zingerman. Really? And Julie and I grew up next door to each other, literally when we were little kids, playing Barbies and driving cars and fake cars around and just doing what little kids do. And little did we know that one day, she was going to grow up and become a rocket scientist, and I was going to be a science teacher. So it's kind of neat, and I'm really proud to have her bring in astronaut James Kelly here today.
Thank you very much. I'd like to thank Kelly Churchman and the staff here at Oxnard High School for having me in. I'd also like to second the thanks to Julie Zingerman. She's down here in front. It's amazing. California has so much to do with the space program. I'm going to talk about what I did as an astronaut, but a lot of it starts right here in California. Julie actually works for a company called Aerojet Rocketdyne, and they're the company that built the space shuttle main engines. We'll see in a video here pretty soon. They also built all the electrical power system boxes that are on board the International Space Station right now. She's a Camarillo Scorpion, grew up not too far from here, and her company actually sponsors me to come out and do these talks when I come to California. So most of the space shuttle that you're going to see and a lot of the space station that you'll see were actually built right here in Southern California. So if any of you guys are looking for a career in aerospace or anything like that, staying right here in Southern California is the place to be. So without further ado, my name is James Kelly. I actually was born in Iowa. I grew up there for the first 18 years. I went to the Air Force Academy in Colorado Springs, Colorado, and joined the Air Force from there. For all of you that are airplane buffs, I flew the F-15 Eagle for about 10 years in the Air Force before I was selected to come to NASA. I became an astronaut in 1996, quite a while ago, and I've flown 2 missions in space, both aboard the Space Shuttle Discovery. For any of you that haven't seen it, the Space Shuttle Endeavour is right here in LA. It's at the Science Center downtown, so if you get a chance to go see that, the vehicle you'll see today in the show is Discovery, but they're almost identical, both of them built here in Southern California. You guys are all here as part of science class, I think, right, Kelly?
Right.
Everyone's here as part of science class. Science obviously is a big part of it. Almost everybody we hire is a scientist, an engineer, we have doctors, we have lawyers, but the common thread amongst everybody is that you apply. So no one becomes an astronaut right out of college. There's no program you can go to that says, I'm going to go to college and I'm going to get a degree in being an astronaut. The youngest astronaut we've ever hired is 27 years old. The oldest is 47, I think. So the average is your mid-30s. That's normally when you get hired to be an astronaut. So you go out and do something first. I was a pilot in the Air Force. You can be a doctor. We've got a veterinarian. We've got geologists. We've got astronomers. We've got teachers that fly in space, that science teachers, math teachers that have flown in space. So we have all these different people that come down to NASA. And we select about anywhere between 2 and 5 years, we do selections. And that's how you get selected to come in. You go through an interview process and all that. There's a lot of physical that you have to do, physical tests, medical tests, things like that. So we're very involved in the medical program. So I think while we're waiting for the video here, I don't want to short the question and answer later. So let's go ahead and start taking some questions and answers now. We'll do that kind of at first and do that. So just raise your hand if you have a question. I'll try to walk towards you. We do bring animals into space. Actually, it was animals that flew into space before people did, both for the Russians, who were the first ones to fly in space, and for the Americans. We still take some animals into space for experiments on board. We've taken worms, we've taken fish, we've taken mice, we've taken all kinds of things up to space with us, and learned some very interesting things from them. As a matter of fact, if you go on the NASA website, you can see last year we had spiders in space because they spin their webs differently in space than they do down here. So we do a lot of things in space where we figured out how structures are put together, and so we took the spiders into space to see how their structures were different. So we do a lot of experiments like that. Yes?
Just going off the Columbia tragedy, what safety precautions have been put in place since then?
Okay, so Columbia, which happened right before us, I'll describe a little bit about what happened with Columbia. So unfortunately, we lost Columbia, and what happened was on their launch, and you'll see this on the launch video if we get up there, we've actually got foam on the tank. And unfortunately, some of that foam off of our big fuel tank falls off. And incredibly unfortunately for Columbia, when they launched, there was a big piece of foam which fell off the tank and hit the leading edge of the wing. Well, when we come back home in the shuttle, the way we slow down is just friction. So like if you're riding your bicycle and you put your hand out, how the wind pushes your hand back, that's the exact scientific principle we use to slow down. So we come down through the atmosphere and the molecules hit the front of the vehicle, and hitting those, every little one slows us down just a tiny bit, and it adds up. But what that does is it makes us very, very hot. So the leading edge of the wing can get up to 3,000 degrees Fahrenheit. So we had a piece of foam hit and actually put a hole in there. So unfortunately, when Columbia came back down, it was like a blowtorch. Instead of the heat getting put around the wings, the heat went through. Okay, I'll come back to your question. So this is our commander. It's Eileen Collins. She's originally from New York. As I said, she was the first female commander of any space vehicle. She was awesome to work for. She now is actually on the advisory board for all of NASA. I was the pilot on board the flight. Actually, here you're seeing me do some robotic work. I don't just fly the vehicle, but we also did a lot of robotic operations with arms. This is Suichi Noguchi. We had a pretty varied crew. Suichi's from Japan. So he's one of our Japanese astronauts, and he was actually the lead spacewalker. So this is him going in the pool to practice spacewalking techniques. Dr. Steve Robinson, who actually right now is a professor at UC Davis, he was our second spacewalker and our flight engineer. Andy Thomas there is from Australia. Although a naturalized American citizen, he was on our flight. He was one of our leads for robotics as well as he helped with the spacewalks. Wendy Lawrence here is a US Navy helicopter pilot, actually flew in the first Gulf War. And so she was our sixth person on the flight. And then the last one right next to her there is Dr. Charlie Camarda. He's a materials scientist PhD. So there's the leading edge of the wing that I was just talking about. That's what protects us when we come home. So we all get in what are called our launch and entry suits. We call them their pumpkin suits there, and those are just pressure suits that we wear when we launch and land. In case we get a hole in the shuttle and we lose pressure, these suits will actually keep us alive. They're like a little spacesuit with oxygen packs on the back and parachutes in case we need to jump out of the vehicle if something else goes wrong. And those are people strapping into the middeck. And this is us on the launch pad. You can see the 3 engines there that they're about to fire up. Those are the ones that Julie built. So you can see the main engines fire up, and then those 2 big white rockets on the side get lit off. The little picture on the upper left, that's the upstairs, that's the flight deck, and you can see it's like a roller coaster. It's shake, rattle, and roll as we head uphill. So those are like 2 big Roman candles on the side. They're solid rocket boosters, and then the 3 main engines are fed off the big orange tank that you can see at the bottom here. That's the coast of Florida that we're leaving very, very fast behind us. After about 2 minutes, those solid rocket boosters come off. You can see they kind of flip away. We'll see another view here. They actually come down under parachute into the Atlantic Ocean. We have 2 tugboats that go out, pick them up, and we'll reuse those. From there, you can see you can hear it gets a lot quieter. Now it's just that big orange fuel tank at the bottom, what we call the orbiter, which is the shuttle on top, the part that looks like an airplane. And that big tank is feeding those 3 main engines that Julie built. So now we're up in space. It only takes about 8.5 minutes. In 8.5 minutes, we're more than 100 miles up, and now we get rid of that fuel tank. So the big orange fuel tank we actually throw away. It's the only major piece that we don't reuse. That actually goes halfway around the world, and it disintegrates over the Indian Ocean. So now we're up in space. Once we're up in space, now we're like a big truck is is the way to look at it. We're actually opening our payload bay doors, and I'm going to continue answering the question from down here below. What precautions did we take after Columbia? Well, one of the big precautions was in Columbia, we didn't know they had a hole in their wing. So we did a lot of inspecting the outside of the vehicle. So these are cameras and radar devices that actually are looking at all of our tiles. The black things are tiles. The leading edge of the wing, you can see the nose cap there on the left. So we went out and we took visual images of everything. There's the hatch that we came in to get inside the vehicle. So one of the things we did after Columbia was we made sure we looked at the entire outside of the vehicle to make sure we had no holes like Columbia did. So there's what the whole shuttle looked like on orbit. That's our payload bay. We're like a big moving truck. The front part, underneath those windows, that's where the people are, where you can see somebody waving at you. So we get up there, we do a lot of burns. You can see things float around, and then when you fire the engines, everything moves the other way. So you got to hang on to something or you're going to go flying. That's the International Space Station. That was our destination. So we're back aboard the shuttle here, and you can see me in the front seats. We're actually working our way through what's called a rendezvous checklist. And a rendezvous is where you bring two vehicles that are separate from each other together. That's a rendezvous and docking. So Eileen's in the pink sweater there on the left. She's actually doing the flying as we come up to the International Space Station. So we get to about 600 feet below the International Space Station, continuing on the Columbia theme. This is another thing we did post-Columbia that had never been done before. We actually got about 600 feet beneath the space station, and we did a 360-degree flip. And the reason for this is so the people on board the station, which is where this picture is being taken from, are taking pictures of the entire outside of our vehicle. We actually found something on the bottom of the vehicle we had to go fix during flight for us to safely come home. So we had similar issues to Columbia, but we were actually able to fix them. Now this is the opposite view. So during that flip, this is what the International Space Station looks like from the shuttle. So this picture is being taken from the shuttle. The International Space Station now looks a lot different because those big gold solar arrays on top, there's now 4 sets of those, 2 on the right and 2 on the left. So we were building the space station at the time that this flight happened. So now we're going to do the docking part. If you look above Eileen's head there on the left, you can see something moving in that window at the top. That's actually the International Space Station coming down. And Eileen is looking at a centerline camera to line things up. So the shuttle's on the bottom, the station is the moving part on the top, and we're about to make 2 spaceships into 1 spaceship. So that's what we call soft dock. We actually put the 2 vehicles together, pumped oxygen between them, and now we're opening up the hatches. This is Eileen on our side, and the commander of the International Space Station there is Sergei Volkov, a Russian cosmonaut who's got more time in space than any other human being, by the way, the guy on the left. He was on board the station when we showed up, and John Phillips is on the right. So the station already had 2 crew members on board. We've had a continuing presence on board the International Space Station for more than 13 years. So we bring them presents when we come. That was actually coffee for John. He'd run out of coffee, so he was really happy when we showed up. And then this is Sergei. This is an old Russian tradition where you actually share bread with people that come into your home. So this is a Russian tradition where when guests come, you share bread with them. So we were breaking bread with Sergei. This is kind of a tour of the International Space Station. We're in the U.S. laboratory floating backwards. All those containers on the left are food containers. You can see exercise equipment beneath us. A lot of scientific supplies on the walls. All those white bags that we're going to fly through now, those are all like water bags. They carry water, which is very important, obviously, up there. Up in space, it's hard to tell which way is which. Everything's right side up, depending on how you're looking. So we're floating from the US segment to what's called the Russian segment. You'll see here in a second. There really is no right side up in space. So you felt like you were right side up. Now you're doing this big turn. Give it about 3 seconds and all of a sudden you think you're right side up again. So it's pretty cool to be up there. You kind of feel like Superman too. This is Charlie Camarda in front of us. Charlie's going to do a Superman right over the top of us. You actually don't use your legs to move. You try not to kick your legs. You move around with your hands. So you'll see him just float over the top of us as we float underneath. And this is the last part of the space station. This is the Russian service module, which is kind of the heartbeat of the Russian segment. There's really two major parts to the space station. So once we got up, we got introduced, we got on board, we had a lot of work to do. So that's the robotics control panel with Wendy and I working the robotics arm to move something from that's the inspection device that we used earlier to check the outside of the shuttle to make sure everything was good. And then we grappled onto that big soup can, which is like a moving van I'll talk about in a little bit. So we had some robotics operation to do, and then a big deal for us was we were going to do 3 spacewalks while we were up there. So Steve and Suichi are going to be our spacewalkers. They're getting their equipment ready to go out on spacewalk. This looks funny. What they're doing is getting all the air out of their drink bags. Those are the drink bags they take out with them when they go to do their spacewalks. Now it's interesting, when they go outside, the white uniforms that they're putting on are really like miniature spacesuits. So when they go outside, they're completely enclosed. They've got oxygen on their backpacks. They're going to put helmets on, which they don't have. They have communication headsets on. But when they go outside, this is a picture from inside looking outside. They go out in what's like a mini spaceship, and that white suit will keep them alive for about 8 hours outside the vehicle. You can see the beautiful Earth in the background. It's kind of a beautiful place to work when you're up there. We're about 250 miles above the surface of the Earth, going 17,500 miles per hour, which is about 3 times the speed of a bullet. Now, also continue, the post-Columbia question was a great one, because continuing with post-Columbia, this was an experiment package on the back. After Columbia happened, we needed to come up with ways to repair the space shuttle on orbit in case it happened again. So this is Steve and Suichi doing a lot of experiments in the payload bay. How can we patch tile damage? And the tiles are those black things that are all along the bottom of the shuttle. How can we repair the leading edge of the wing? So we did a lot of experiments trying to figure out how that would work. And so this is almost like a gap filler that you would use on your garage or in your house when you've got a crack in the wall. Now we also, this is the space station robotic arm here. You can see on the end of the robotic arm there's actually a person. They actually lock into the bottom of it like you're going skiing, and we drive them around on the arm. And this is what it looks like inside the helmet of the spacewalker. They've got a camera right on the helmet. So this is Suichi. He's up on the International Space Station truss. You can see the shuttle there and then the Earth in the background. This is what it looks like to be a spacewalker. So if you were outside in one of those white suits, this is what you'd be looking at. It's, being an astronaut is not a job for the faint of heart. So that's Suichi out on what we call the diving board. So he's got his feet connected in like he's skiing, and he's carrying around what's called a control moment gyro, and that's what keeps the space station oriented. It's what's like a gyroscope that will keep it pointed in the right direction. We had to replace one of those. And Suichi thought he did a really good job. You can see all the time in the background there on the Earth, you can see those swirls in the clouds. We see all kinds of incredible things up there on orbit. Another view of a spacewalk. You can see Steve way over there on the left of the picture. You see an astronaut underneath the shuttle? That was Steve. We actually had a problem underneath the shuttle on our flight where we had to go in and pull a couple things out. So we'd never taken anybody below the shuttle in flight before. The only time this was ever done in the entire shuttle program. You can see in Steve's right hand there's something sticking out between the 2 tiles. He had to go down there with his hand, and there were 2 of these that he had to pull out from between the tiles because they were going to be a problem if we came back on re-entry. So Steve went down and fixed the vehicle so we could fly home. You can see the Earth in the background with the light in the dark. These were the 2 things that Steve pulled out between the tiles. They're called gap fillers, and we needed to bring those back in so that they wouldn't hurt us when we came back down. And then finally, this experiment done inside, this is how we were going to, if we had a hole in the leading edge of our wing, we were going to just put this patch on there that actually has a toggle bolt behind it to put it in place. So it's almost like working in your garage, same kind of tool as those things. Once we were done outside the station, we had a lot of work to do inside the station as well. That big box that you see John Phillips putting in is called a payload rack. And we have several dozen payload racks that we put on board. That was a human experiment one. And then we moved about 7 tons of equipment. So this is what you want to do down here on Earth when you have to move a couch. Yeah, exactly. You wish. You just want to push it like this. The hardest thing for all of you guys that play baseball or softball or anything like that, the hardest thing is when you first start throwing things on orbit, you hit the ceiling with everything because you're used to putting an arc on it. When you're in orbit, you just push something, it's going to continue going that direction until it runs into Wendy. That's a big water bag there that we saw before. Those are about 20 gallons of water in each of those bags. So that soup can that we saw earlier that the robotic arm went on, that was like our moving van. This is inside that soup can. So it had 7 tons of equipment inside that soup can that we actually got out of there, put on board the space station, and then we got a lot of things out of the space station, put them back in that soup can, and brought them back down here to Earth, which is very important to bring the experiments back. And there's the soup can right there. So that came up in our payload bay. We took it out, we attached it to space station so we could get into it. Then we closed it up, and now we're going to put it back in the payload bay. This is the whole crew getting together for a meal down in the Russian service module. This was the night before we left. Suichi there has a copy of the ship's log that we all signed. Everybody signs the ship's log. And then it was time for us to say goodbye to our compatriots up there on the space station, get back in our space shuttle to come home. John and Sergei were actually up there alone, just the two of them on board the space station for about 6 months. So now what you can see is we're leaving the space station, so that's the space station on the upper left and the shuttle on the lower right, and you can see now we're 2 spaceships again. So this is called undocking, where we actually become 2 spaceships. And at this point, I've switched with Eileen, and now I'm flying the vehicle. And when we came up, we did that 360-degree flip so they could take pictures of us. Now what we do is a 360-degree loop over the space station so we can take pictures of them. So this is us flying a complete loop around the space station. And once again, it's so beautiful to be able to look down at the Earth in the background. You can see the curvature of the Earth on the edge there. So I can actually tell you the Earth actually is round. I've seen it. This is a snowstorm in space. Actually, it's not. This is frozen water that's being dumped over the side. Stupid astronaut tricks. Being in space is a lot of fun. You're working really hard. You're working like 16, 17 hours a day, but it's a lot of fun too. That's actually just a little trash thing there. And you can see it just keeps going until it stops, until it hits something. Rotational experiments in space. People ask how we sleep. Eileen's getting into our sleeping bag there. You just get in a sleeping bag, you strap it to the wall. I've slept on the wall, the ceilings, the floor. I've slept in the middle of the thing. That's Eileen. That's actually our bicycle. She's using that incorrectly, so don't try that at home. And then Charlie's working with, we don't really cook on orbit, but we rehydrate and reheat food. We actually have a water dispenser and an oven there. And it's kind of funny playing with things. This is a water droplet that just put a drop of orange juice inside. And Andy's doing a fluid experiment here. But you always have to clean up after yourself. We have a lot of fun with food in space. You actually have to go chase your food down. It likes to fly away from you. We have contests to see how far you can throw an M&M and not hit a wall. So unfortunately, the fun has to stop sometime. So when it's time to come home, we close those payload bay doors again. We get back in our pumpkin suits, our pressure suits to come back home, strap everything down. You can see everything strapped down on the floor and strapped down on the wall. That's a helmet bag that's floating right there. There's a helmet in there for one of the crew members. And then it's time to come home. So remember the Columbia thing I talked about? We actually get about 3,000 degrees on the leading edge of the wing. You can actually see the fire. That flashing is the fireball behind us. We actually have about a 20-mile trail of fire that goes behind the shuttle. And that's it right there. That's looking out the back window, and that really hot thing in the center is our tail. So, and that's what happened with Columbia, the leading edge of the wing with the hole in it. That 3,000 degree heat got inside the wing where the aluminum is, and aluminum will melt about 300 or 400 degrees. So that's why, and the wing just fell apart. So this is an infrared picture, so it's a heat signature. You can see the whole thing's really hot coming back down, and especially the nose. That bright point right there is the nose cap because it has more heat than any other part of the vehicle as we come back. So we actually landed at Edwards, so we flew almost right overhead Oxnard when we were coming back down and landed at Edwards, California right before sunrise. So this is Discovery landing on the 2-mile runway up there at Edwards Air Force Base, California. And then this is about 3 hours later after we've taken care of the vehicle, we've done some medical testing, got out of our pumpkin suits. We actually got a chance to walk around underneath Discovery after we were done flying. Everybody's having a good hair day. And that was the end of Discovery STS-114. And we actually had on our flight, very similar to Columbia, where they had a big piece of foam come off. We had one come off of our flight. Luckily, we had the cameras that you saw. It actually missed our wing, so we were fine. After Steve pulled those things out from underneath the tiles on the bottom that you saw, our vehicle was safe, so we came home and we were fine. But the Space Shuttle program shut down again for another full year while we did some more fixes after Columbia. So we were a test flight just to see if we could work. And had the question asked earlier before you guys were here, if something had been wrong with Discovery where we couldn't come home, we actually would have stayed on board the space station until a rescue crew came up. So with that, I'll move on to more questions and answers. So.
If you have timer, someone with the International Space Station will have some problems. You may have to evacuate from there.
Yeah, we're not going to have to evacuate the space station, but we are having problems on board the space station right now. We have what are called external cooling loops. And it's kind of interesting in space. Everybody thinks it's cold in space. Well, it's either cold or hot. If you're in the shadows in space where you can't see the sun directly, you're 200 or 300 degrees below zero. If you're in sunlight in space, you're actually 300 to 400 degrees above zero. That's why you see those big, thick white suits. We actually have a lot more problems rejecting heat than we do staying warm. And so on board the International Space Station, there's 2 loops that actually do the cooling for the space station. So, and they run throughout the entire space station. Well, one of those, a pump package that actually does the fluid pumping, there's a valve that's not working. So we essentially lost half our cooling on board the International Space Station, which is fine. We're actually built to be redundant. So we are fine on one loop. But the problem is if that second loop goes out, then we'd have to evacuate. So right now, we've been busy all week with preparations to go out and do 3 spacewalks. And the first one will probably be Saturday. So if you guys are Saturday, hop on your TV, go to NASA TV. They'll probably have some coverage on the normal news networks. But we'll be doing 3 spacewalks, one on Saturday, one on Monday, and probably one on Christmas morning to go replace that pump package, and that'll bring us back up to full capacity. So the good news is there's almost nothing that can break on space station that doesn't have a backup. And so we have to go fix that to get back what's called redundancy, which means you can do it more than one way. And Kelly, just give me the high sign when we get, or Julie, give me the high sign when we get close on time. Let's see. There was a question right here. Yeah.
Your first time going in space, was it scary?
It was a little bit scary. Actually, the funny part is you train so much to go in space that you're not so much scared as you're excited. And the thing that I was doing in my head, which a lot of people do, is some people call it the pilot's prayer, is, please, dear Lord, don't let me screw up. You know, you've worked for all those years and you're getting ready to fly and you don't want to throw the wrong switch or do the wrong thing. I actually didn't realize I was in space until about 10 minutes in, because you're so busy. As the pilot, as you saw on the front of that cockpit, I was actually in charge of about 400 switches, dials, gauges, things like that. And there's so many things we have to do that I didn't even realize until I'm working like this. And I just glanced up and we were flying over Africa and I saw the whole vista of the world out in front of me. And I looked up, I looked back down, I said, oh my gosh. And so I grabbed Paul Richards, who was behind me, and pulled him up and said, stop what you're doing and look out the window for 2 seconds. So it was an incredibly exciting thing. You wait your whole life to do it. I flew my first flight, I guess I was about 35 maybe, so, and I'd want to do it since I was 5, so it was much more excitement than being scared. That's, I've already had one from you, so. It is true that we have not been on the moon for years. Kind of a sad thing. We last went to the moon in 1972. It was the last time any human walked on the moon. There's only been 12 people that walked on the moon, all Americans. We're trying to go back there hopefully sometime in the next 20 or 30 years. The latest thing happening with the moon, if you guys saw it in the news, is the Chinese actually just put a rover on the moon. So there's only been 3 countries ever that have soft landed something on the moon. The Russians, they were the Soviet Union at that point, and the United States were the only country to put people on board, people on the moon, and now the Chinese have landed a rover on the moon. So we're hoping to go back there before too long. I'm gonna wander over this way. Anybody over here with questions? Yes, sir. Let's see, Sergei has been on orbit for more than 2 years total. Sergei Volkov, he's got more time in space than any other person, like I said. He was a really interesting story. Sergei was like probably one of the best astronauts or cosmonauts ever to fly. He actually, on one of his flights, okay, now I'm out of range. I'm gonna walk back over here. Okay, Sergei, on one of his flights, actually launched from the Soviet Union, and while he was in space, the Soviet Union dissolved. So he actually stayed up there for 10 months while they tried to decide how to get him home, because he couldn't come back to his home country, because they actually do their launches not from Russia itself. They do it from the Ukraine. So he launched from the Soviet Union and landed back into a different country than he left from. So he's got more time in space, and he's an incredible cosmonaut. He's one of the best I've ever seen. See, somewhere here in the center, anybody questions? Right here. Our objectives at NASA are kind of twofold. One is scientific benefit. The International Space Station was specifically built for scientific purposes. So we do a lot of experiments, material science, fluid experiments, a lot of medical research. And so we're doing things to look at osteoporosis, cancer cures. We're doing things, fluid dynamics. We're looking how we're going to be able to send people from here to Mars. So we do a lot of radiation things. So we're trying to do a lot of things that benefit people here on Earth, but also will allow us to go further out in the solar system. So what we're trying to do now at NASA is, if you guys have heard of the Commercial Crew Program, we don't have a vehicle right now from America that can take people to space. We retired the Space Shuttle in 2011, which is why Endeavour is sitting here at the Science Center, because we're not flying it anymore. So we fly to space now with the Russians. They're taking us back and forth. But we're trying to get commercial companies, not NASA, to build vehicles to fly to the space station so we can stop going to the International Space Station. And our vehicles that NASA's building, we're going to try to take to the moon and to Mars and further out in the solar system. So NASA's goal is to continue doing the International Space Station, but to go much further out with human exploration into the solar system. So.
Explain the concept of time. Like when you're up there, how much time has elapsed here on Earth as far as?
Yeah, time on Earth, on orbit is relative. If anybody's familiar with Einstein's theory of relativity, I'm not going to go too much into it, but I'm actually a few microseconds younger than I should be because I flew in space. When you go faster, time slows down. Now, it's pretty infinitesimal on board the orbiter, but if we fly to other planets and other parts of our galaxy, depending on the speed you get to, it could be quite a difference. Like if you flew to Alpha Centauri and back and you were close to speed of light, it might be quite a bit of time that's changed. So time is not as constant as we think. It depends on speed. So you're absolutely right. So I'm actually a little bit younger than I should be from the time I was born because I flew in space. I'm actually taller in space too, because you get out in space, there's no gravity, so your spine stretched out. So I gained about an inch and a half when I was in orbit. Unfortunately, you lose it when you get back, so you don't get to keep that. But yeah, so there's a lot of physical changes that happen there. See, sir. Walking on Earth after you've been in space can be really interesting. And everybody reacts differently, but you have problems sometimes going up and sometimes coming back. For us, coming back, there's two main issues. One is, if you probably noticed in the video, now I've got a pretty big head anyway, but if you notice in the video on orbit, everybody's face is kind of puffy. Well, what happens if you think about it is I'm standing here, I've got all the fluid in my body, but a lot of it's down in my legs, right? Because you have to fill that, and what you really need is blood volume between your heart and your head. So you got a lot of fluid in your body to make sure you have enough to get to your brain. When you go on orbit, all that fluid shifts up, and now you've got way too much fluid, okay? So these little receptors in the back of your neck say, I've got way too much. So you spend the first day in the bathroom, getting rid of all the fluid, right? So when you come back, now you don't have enough fluid. So on orbit, to be fully hydrated, when you come back down here, you're really dehydrated. So I actually, before we come back, we take salt tablets, and I downed 3 gallons of water before I came back to try to get the fluid back in your body. So some people come back, especially if you're tall and skinny, not my problem, but if you're tall and skinny, you have a real problem with that blood volume between your heart and your head. And so some people feel really faint when they get back, and they actually have to lay down. You have to give them an IV and pump fluids into them. And then the other thing is you've got your middle ear, which you guys have probably studied, which is your balance system. Like my middle ear right now is telling me I'm standing up. If I lean this way, it keeps me from falling completely over. If you move it real fast, it does things. Well, that all shuts off when you're on orbit because it's all based on gravity and those little stones in there that move on the hairs that tell you where your balance is. Those don't work in orbit because your little stones are just floating. So you don't have that same thing. So some people come back down and they're very dizzy. And you can see it like when they try to walk around corners, if they want to walk around here, they start walking around here and they'll actually come over and they'll run right up against the wall because you just can't do that. So actually we get the field sobriety test that you get, don't ever do this if you ever see people drinking and driving. We get that same test that we have to do and have to pass before we can drive because some of the effects are much like being impaired. Your vision doesn't work quite right, your head's kind of spinning, so those are the two problems we have. So it can be very difficult coming back down. And some people are different. Some people it takes 2 or 3 days. Some people are back right away. It's all, and you can't, there's no way for us to test that, but you just have to go do it and see. So let's see, I haven't asked many from over there, so I'm not sure if I can walk all. Anybody from over the side of the room? Way in back, you guys can jump up and scream. Go ahead. Have we developed any? No, as far as I know, Sergei has not developed cancer. That is something that we look for as an astronaut population. As a matter of fact, we have a medical thing in place where they'll check us for the rest of our lives. So they're doing this, it's called a longitudinal study, which just means it's a long study of the effects of spaceflight. So every astronaut who's flown, we check them every year to see, and we keep track of who gets cancer, what kind of cancer they get, and see how different that is from the normal population. And you guys might have seen in the paper, we're constantly doing studies down here on Earth, like they're putting people on bed rest for a year, where you have to lay horizontal for a whole year, because that kind of mimics space flight where your body's not taking, as I'm standing up here, my muscles and my bones are doing a lot of work. You go up on orbit and your bones will actually go away. They'll actually just start leaking structure because you don't need them. And so that's a very big problem, especially for women, because becoming osteoporosis, which is where your bones aren't as thick, we have that problem in orbit. So we do a lot of studies on the ground. We do a lot of comparisons. So far, there's a couple areas where we do worse in space, we know. And so far, the cancer rates haven't been higher, but vision problems we've discovered are a big deal. When you go up in space and then come back down, there are some vision problems, some which may not go away. And then the amount of radiation you take obviously is a lot higher. So far, it hasn't resulted in a higher cancer rate that you can tell statistically, but it may just be we're not a big enough sample size yet. So for those of you that have studied statistics. Okay, I got one more question. Yes, sir. I've heard of the movie Apollo 18. I have not seen the movie. I have not seen the movie. I don't know how accurate Apollo 18 is. Apollo 13 is a great movie and is very accurate, so I can vouch for that one. Yeah. Yeah, it's like a horror movie, I think, yeah. Okay, I think that's it for this round. Thank you very much. I want to say one thing before I quit, and that's, I get a lot of questions about this. People ask me how I became an astronaut. I became an astronaut because I wanted to be and I never gave up. So whatever your dream is, whatever you're sitting here dreaming about being, keep going for it, because the only reason I got this was because I applied to go do it. So whatever your dream is, make sure you keep following it and find the people that will help you, and maybe someday you guys will be walking on Mars. Thanks, everybody.